Dear all, welcome to Simplified Triple Studies. In this video, I will be discussing most important MCQ based on logical operation in 8085. Before moving on to the session, let's get understand what do we mean by logical operations in 8085. In the previous video, I have discussed about different addressing modes of 8085 microprocessor, and the same thing is available in both I button and the description box. Kindly watch those videos and that will be helpful for your competitive examination. However, let us discuss logical operations in 8085. You know what is Boolean algebra, what is a logical operation, and you must have familiar about AND gate, NAND gate, OR gate, XOR gate, etc. in the digital electronics. You know that a microprocessor is going to support these logical operations such as OR, AND, XOR, etc. Actually, one of the operand will be accumulator in case of the logical instructions which is taken place in 8085 microprocessor. Okay, and the logical operation will be taken place bit by bit. Okay, you know how to operate and how does OR gate operate. Then in 8085 microprocessor, the destination operand for the instructions is always accumulator register. That point you have to remember. Same thing I have written over there. Then the result is also stored in the accumulator. So after the logical operation, result will be stored inside the accumulator. That is what exactly happening in case of 8085 microprocessor. So you need to understand the basic operations like OR and XOR will be taken place in 8085 microprocessor, and also after the operation the result will be stored inside accumulator, and also one operand is actually called accumulator. So these are the basic information you have to understand. Let us straight away move on to 10 important questions. I will be scrolling down. Take your time and note down the right answer. Definitely to help you to have a self-evaluation. Okay, hope you are noting down the right answer. I am going to start the discussion. Yes. Read the first question. ANAB. Identify the logical operation takes place in 8085 microprocessor. ANAB is nothing but so B is a register and A is also a register. A is known as accumulator. First of all, the AND operation will be taken place. A dot B. That will be stored inside the A register, or you can call it as accumulator. This is actually representing accumulator. Accumulator and the contents in the B register. The bitwise operation will be taken place. Bitwise AND operation. That is why it is dot. Clear? So which is the right answer? Please select option B. Hope you are understanding. Question number B. Please read the question B. ANAB. Where did the result store? Of course, the result will be definitely stored in accumulator. That means A dot B, that is going to store in A itself, accumulator. That is what we are familiar in the first question. Question number 3. How do you clear only upper and lower nibble of an 8-bit data? For example, we are having an 8-bit data. Look at this. 1 1 1 1 0 0 1 0. So these are the nibbles actually. Set of 4 bits are called a nibble, that you know, right? So this is your, let me call lower nibble. This is your higher nibble. The question is, how do you clear either upper or lower nibble? Suppose I want to clear the lower nibble. So what I have to do? So I have to perform AND operation. Here what I am going to do is, I will be adding 0 here. 0 0 0 at the lower nibble. Upper nibble I am not changing anything, like the same. Now you can perform the AND operation. So 0 and 0, that will be 0. Correct, no? And 1 0 means 0. 0 0 0 0 0 0. So what is going to happen? The lower nibble becomes 0. So here there is no change. One AND operation, A dot B, 1 dot 1, 1 dot 1 1 1 and 1 1 1 and 1 1. So what happened right now? The lower nibble become 0. To clear the lower nibble or upper nibble, I have to perform logical AND instruction. I think it is very clear to you. Next, another related question. How do you set only upper or lower nibble of 8-bit data? Set means to make 1. Okay. For example, so we are having the data 1 0 1 1 and 0 0 1 1. One example I am going to explain. So now what I want to make is, I need to make the higher nibble 1. This is your higher nibble, correct? Higher nibble, and this is your lower nibble. Higher nibble need to be set 1. So what I have to do is, so do like this. Here I can put 0 0 0 0. I don't want to change lower nibble, so you can do the OR operation. 1 1 or 0 1 1 or 0 1 0 or 0 0 0 or 0 must be 0. There is no change. But in case of higher nibble, 1 or 1 1 1 or 1 1 0 or 1 1 1 or 1 1. So definitely what happened? The higher nibble became 1. That means I could set higher nibble. So this is called OR operation. Here you are supposed to perform the logical OR instruction. Please select option B. Okay, in this session, please select option B. Question 5. How do you complement only the selective bit? Here you are supposed to use the Xor operation. Xor. You must have familiar about Xor operation, correct? Okay. So Xor means if higher bit or lower bit, like 1 XOR 1, what is the operation? 1 XOR 1. 1 XOR 1 will be 0. 0 XOR 0 means that is also 0. Okay, and one input should be high, another input should be low. Then only you will be getting the higher value. Okay, so now let us say one example. I have to perform the XOR operation. Here 1 1 1 0 1 1 1 0. What I want to make is, I need to make some typical bit to 1. Okay, so what I have to do is, this is your higher nibble, this will be lower nibble. So let me write 1 1 1 1 0 0 0 0. Now perform it. 0 0 means it will be 0 only. 1 0 it become 1. 1 0 it become 1. 1 0 it becomes 1. Here also the same thing is happening. 1 0 1. This becomes 0 0 0. See, a typical, only a specific bit become 1. So here you are supposed to perform the XOR operation. I think it is clear. Now question number 6. Identify the instruction. Here the right answer is, here see the changes. In if you look at the changes, what you can observe is, rotate left with carry. R else is the right answer. Here what is going to happen? It became 1 here. You can see the shifting. See, look at this. Shifting has been observed here. Okay, that is called the rotate left with carry. Question number 7. Identify the instruction. Look at the flow here. Here what is the flow you are observing? See, rotate right with the carry. RRC. Please select option B. RRC is the right answer. Now dash instruction is suitable for boot algorithm. So which is the right answer? So rotate right with the carry. RRC is the right answer. Please select RRC. Okay, rotate right with the carry. That is suitable for boot algorithm in computers. So that is important. Then what is the full form of CMA? CMA stands for. So you please identify what is the CMA. It is important. CMA, full form of CMA. Complement accumulator. So that is the word meaning of CMA. Okay, complement accumulator. So A, for example, A become A bar. That is the word meaning of complement accumulator. Okay. Last question. Dash is known as non-destructive subtraction. So identify which is the non-destructive subtraction. That means CMT. CMT is known as non-destructive subtraction.